Audio Jungle.
Acid-base titration. Today we are going to lab of acid-base titration. So first one, we should know that what acid-base titration is. An acid-base titration is a process used in quantitative chemical analysis to determine the concentration of a known acid or base. Acid-base react with each other to form salt and water. There are four types of acid-base titration. First one is titration of a strong acid with a strong base. And the second one is titration of a weak acid with a strong base. And the third one is titration of a strong acid with a weak base. And the last one is titration of a weak base with a weak acid. Titrant or standard solution is the solution with a known molality. And titrant or sample is the solution with an unknown molality. And this is hydrochloric acid react with sodium hydroxide to form water and sodium chloride. This is the chemical reaction that we are going to use in the lab today. This kind of titration is titration of strong acid with strong bases. When hydrochloric acid and sodium hydroxide base is added into the solution, hydrochloric acid ionized into proton and chloride ion. Sodium hydroxide ionized into sodium ion and hydroxide ion. Sodium combines with chloride to form sodium chloride. Hydrogen ion combines with hydroxide ion to form water. In this graph, it shows equivalent point. Equivalent point is a point when pH is neutral. It means that the amount of sodium hydroxide is equal to the amount of hydrochloric. But in this lab, we use phenolphthalein as a pH indicator. So we have to use the endpoint instead because phenolphthalein changes color when pH is around 8.4 to 9.0. On the other hand, we can know that pH is 7 when titrant is added because phenolphthalein still remains colorless. This picture shows that phenolphthalein changes color when the pH is around 8.4 to 9.0. Before that, it remains colorless. Meniscus. The meniscus is the curve seen at the top of a liquid in response to its container. The meniscus can be either concave or convex depending on the surface tension of the liquid and adhesion to the wall of the container. In this lab, we focus on concave meniscus. When we read a scale of concave meniscus, we have to read the bottom of the meniscus. Equipment included in this experiment: 1. Aluminium flag or conical flag. 2. Burette. Burette is used for dispensing of variable and for measuring amount of a chemical solution. The flow of liquid from the tube to the burette tip is controlled by the stopcock valve. 3. Pipette. Pipette used for transferring or measuring out small quantities of liquid. In this experiment, we use pipette instead of cylinder because pipette is more appropriate and easier to use than cylinder. 4. Three-way pipette filler or pipette valve is used for pipetting. The attachment is placed over the mouth of the pipette. Squeeze the air valve A and the bulb simultaneously to empty the bulb of air. Gradually squeeze the suction valve S to draw liquid into the pipette, and squeeze the valve E to withdraw liquid out of the pipette. 5. Phenolphthalein. Phenolphthalein is a colorless weak acid. It turns colorless in acidic solutions and pink in basic solutions. 6. Dropper. Dropper used to drawing in a liquid and expelling it in drops. 7. Unknown molality of hydrochloric acid solution. 8. 0.1 molar of sodium hydroxide. Procedure: 1. Pipette 25 ml of an hydrochloric unknown solution into an aluminium flag. 2. Pour the standard solution of 0.1 molar sodium hydroxide into burette. 3. Add 2 to 3 drops of phenolphthalein indicators into a flask. 4. Add the standard solution from the burette into a flask by swirling the solution until the color of the indicator changes. 5. Repeat all steps for 3 times. Result: for the first trial, we use 3.3 ml of sodium hydroxide to titrate with hydrochloric solution. For the second trial, we use 3.0 ml of sodium hydroxide to titrate with hydrochloric solution. For the third trial, we use 3.05 ml of sodium hydroxide to titrate with hydrochloric solution. The average volume of sodium hydroxide that need to titrate with the unknowns is 3.12 ml. When the sample titrate with unknown completely, the color of the solution will change to pale pink like in this picture. Graph. From the graph, it shows that the pH value of the solution will slowly increase at the beginning of the titration, and then rapidly increase during it reaches the equivalent point, which has pH value around 7 for this experiment, and the end point which has pH value more than 7. After that, it will back slowly increase again. For finding the concentration of unknown, we use formula as C1V1 equal to C2V2. Specific for this experiment, substitute C1 equal to X, V1 equal to 25 ml, C2 equal to 0.1 molar, and V2 equal to 3 ml. We can know that the molarity of this unknown hydrochloric solution is 0.012 molar. Conclusion: titration is the process of finding the molarity of unknown hydrochloric solution. In this experiment, 3.12 ml of 0.1 molar sodium hydroxide is needed to titrate with the 25 ml of unknown hydrochloric solution to change the color of solution into pure pink. But if we look into the graph, which shows that 3 ml of standard solution is needed. After the calculation, we found that the percent yield of that experiment is 104%, and the molarity of the unknown is 0.012 molar.